So in this video, I am going to tell time complexities in increasing order. So the first one is O of 1, which is also known as constant time. Here, the algorithm execution time remains constant regardless of the size of the input. For example, accessing an element in an array by its index, whether the array has 10 elements or 1000, accessing a specific index takes the same amount of time. The second one is O of log n, which is also known as logarithmic time complexity. Here, the algorithm time grows logarithmically as the input size increases. For example, binary search in sorted list. With each comparison, the search space is reduced by its half. Then third one is O of n, which is also known as linear time. Here the execution time of an algorithm is directly proportional to the size of the input. Its example can be a simple linear search through an unsorted list. The fourth one is O of n log n, which is also known as line arithmetic time. This time complexity is often seen in algorithms that divide the problem into smaller subproblems and solve them independently, each taking O of log n time. For example, merge sort or heap sort. They involve dividing the array into smaller parts and sorting them individually. Fifth one is O of n square, which is also known as quadratic time. Here the execution time is proportional to the square of the input of the size. Here you can take the example of bubble sort where a nested loop iterating over each pair of elements in an array to sort it. Then sixth one is O of n cube, which is also known as cubic time. Here the execution time is proportional to the cube of the input of the size. Its example is algorithm with three nested loops. It often found in certain matrix operations. Then seventh one is O of 2 to the power n, which is also known as exponential time complexity. Here the execution time doubles with each addition to the input of the size. For example, brute force approach to solve problems like traveling salesman problem. Then the last one is O of n factorial, which is also known as factorial time complexity. Here the execution time grows factorially with the input of the size, making it highly inefficient for large inputs. For example, permutation or combination problems often involve factorial time complexity. And for more such videos, subscribe to Code Family.